Hey guys, today is our last lesson of Unit 3 and we are going to be talking about higher order derivatives. Higher order derivatives mean like second derivative, third derivative, fourth, so on and so forth. And it just means that you keep taking the derivative of your answer to get the next derivative. However, there are a couple, I don't want to necessarily call them tricks, but a couple problems that when we do higher order derivatives, we have to kind of find a pattern. So if I start with e to the u, well, we've been working on chain rule, and the derivative of e to the u has been whatever u prime times e to the u is. So that's for the first derivative. But what if I wanted the 20th derivative? What will end up happening with e to the u is whatever u prime is, each derivative is going to be taking u prime that you had from the first answer times another u prime. So we end up with u prime to whatever power we're looking for. So in this case, it would be the 20th power times e to the u. And that'd be the same for the 100th, the 200th, so on and so forth, okay? Sine and cosine are not as friendly because the derivative of cosine is negative sine, but the derivative of sine is positive cosine. So they alternate not only trig functions, they also alternate signs back and forth. So anytime you're asked a higher order sine or cosine derivative, we're going to find, I would advise finding at least the first 4 or 5. And then you're going to look for the pattern. Okay, and I have an example of that here in a minute. Yeah, down here at the bottom, I ask you for the 25th derivative of cosine. Okay, so we're going to look for a pattern. Okay, so f of x equals 5x to the 7th, blah, 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 blah. Find f 3 prime. That means I'm going to find 3 derivatives. So it's just going to work in order. I find the first derivative. Okay, that's stuff that we've been doing. We were doing those kind of derivatives last unit. Okay, now the application of this is now, I didn't want the first derivative, I want the third. Well, to get to the third, I have to take the first, then I take the second derivative. So now I'm going to take the derivative of the answer I got for the first derivative. Oh, that should have been cubed, sorry. Okay, so there's my second derivative. Then I can finally get my third derivative by taking the derivative of the second derivative. Okay, so higher order derivatives just mean you take a derivative and then you take the derivative of the answer. And then you do another derivative of that answer, and so on and so forth, okay? So number 2, I'm asking you for the second derivative, but I'm also giving you sine of u. Okay, so this is stuff that we've been doing, so we're going to figure out what u is and take its derivative. And then we're going to decide what fu is. And take its derivative. We multiply those things together, so I would have 3 times cosine of what was u. There's my first derivative. I didn't ask you for the first derivative, though. I asked you for the second. So that means I'm going to do the derivative again, but now of this answer. Hey, got a u again. I take the derivative of each of those. And I multiply together. Okay. So higher order derivatives is not learning anything new. It's just taking rules that we've already learned and applying them more than once, okay? So number 3, yes, I'm asking you for a second derivative, but I've also given you a product rule. So first derivative, we're going to take the product rule, derivative of the first, times keep the second. Plus keep the first times derivative of the second. And then I'm going to clean all this up a little bit. So that's the answer to my first derivative. Why I wanted to go ahead and work that out, because they were simple distributing. Because now my second derivative isn't too awful complicated. It's a straightforward derivative. Okay. Number 4, I need the 10th derivative. Yes, you could work out all 10 derivatives. But anytime you have e to the u, you can follow a pattern. If u is 2x, the derivative of u is 2. Which then means I have e to the u, but the derivative of e to the u is still e to the u. So my first derivative is 2e to the 2x. And I'm just proving a point. Second derivative, I'd have to choose my u, which u prime would still be 2, times the derivative of e, which stays e. There's already a 2 there, which would make 4e the 2x. The third derivative, I'd have to use a u again. I get a 2 times the 4 that was already there, 8e the 2x. Notice the pattern. First derivative, I have 1, 2. Second derivative, I have 2 2's. Third, 3 2's. So the 10th derivative would be 2 to the 10th power times e the 2x. Yes, I will let you leave 2 to the 10th like that because 2 to the 10th power is a very large number. Okay? Kind of a good rule of thumb, if your answer is anything over like a couple hundred, so like 4 cubed is not bad, that's 64. Okay, but 4 to the 6th, that starts getting rather large. So use your best judgment. Okay, if you're going to get a huge number when you raise something to an exponent, just leave the number to the exponent. All right. I'm going to have a u. Its derivative is 5. Fu is 3 cosine u, and its derivative would be negative 3 sine of u. So then I multiply those together to get my first derivative. But now to get my second derivative, I have to use a u again. third derivative. I'd have to do a u again, but hey, somebody's starting to notice a pattern. U prime is still going to be 5, but this time I've got negative 75 cosine of u. Cosine is negative sine, but that's already negative, so I end up with positive 75 sine of u. Multiply those together, 75 times 5. All right, let's go one more time. I know I've got a u. U prime is 5. Fu would be 375 sine of u. Derivative of sine is cosine, so I get 375 cosine of u. Multiply it together by my u prime. All right. So typically going to the fourth derivative on sine and cosine is far enough, because after the fourth derivative, they start repeating themselves. So let's look at the pattern. Okay, negative sine, negative cosine, positive cosine. So the fifth derivative is going to end up being a negative sine. Sixth would be negative cosine, so on and so forth. So if I want the 25th power, well, I know the fifth is going to replicate the first. The first one is a negative sine, so guess what? The fifth is also going to be a negative sine of 5x. But I'm going to be multiplying by, anybody notice the pattern? The 3 stayed constant, and then each additional time we multiplied by 5. And if I'm on the fifth power, that would be 5 5s that I would multiply by. So let's use that same logic for the 25th. I'm going to kind of get rid of all this jumbled mess. Okay, so the 25th power. I know I have to have a 3 because 3 was already in front of there. 5 to the, how many powers am I going to? The 25th. We said that the fifth derivative would line up with the first, so what do you think the 25th will line up with? Also the first, which is a negative, so I know I need a negative sine 5x.
And Kayla Stewart to the main office, please.
Okay. So give your homework a try. If you have questions, please feel free to email me. I know some of you say that you'll email me, but then you never do. So I just continue to ask. Please email me if you get stuck. Like I said, this is the last lesson for this unit. You have this homework assignment. There's a review posted. A key will be coming up shortly. And then within the next day or so, I will be sending out a test.